Applications of Soundwave. Sonar. Sonar stands for Sound Navigation Ranging. Sonar is used in navigation, forecasting weather, and for tracking aircraft, ships, submarines, and missiles. Sonar devices work by bouncing sound waves off to determine their location. A sonar unit consists of an ultrasonic transmitter and a receiver. On boats, the receiver is mounted on the top of the ship. To measure water depth, for instance, the transmitter sends out a short pulse sound wave and later the receiver picks up the reflected sound. The water depth is determined from the time elapsed between the emission of the ultrasonic sound and the reception of its reflection off the sea floor. A ship sends out ultrasonic waves in order to detect the schools of fish swimming beneath. The waves reflect off the fish and return to the ship, where the detected and depth of the fish is determined. Echolocation. In 1944, Donald R. Griffin coined the term echolocation. Echolocation is used of echoes of sound produced by certain animals to detect obstacles and food. Animals that live where lighting is unpredictable use echolocation. Some of these animals are bats, porpoises, some kind of whales, several species of birds, and some shrews. The first step in echolocation is emitting a sound. High frequency sound provided better resolution of target than lower frequency sounds. Not even animal uses ultrasonic sound in echolocation, but they are more effective. Still, sounds used in echolocation can be produced in the voice box, the mouth, or some other parts of the head. Then, a highly refined auditory system detects the returning echoes. In order for echolocation to work, the outgoing pulses of sound need to register in the organism's brain, so it can be compared to its echo. Using echolocation, some animals can effectively catch prey and see in the dark. Echo. In audio signal processing and acoustics, echo is a reflection of sound that arrives at the listeners with a delay after the direct sound. The delay is directly proportional to the distance of the reflecting surface from the source and the listener. Typical examples are the echo produced by the bottom of a well, by a building, or by the walls of an enclosed room and an empty room. A true echo is single reflection of the sound source. The word echo derives from the Greek echo, it from echos, sound. Echo in the folk story of Greek is a mountain nymph whose ability to speak was cursed, only able to repeat the last word anyone spoke to her. Some animals use echo for location sensing and navigation, such as dolphins and whales and bats. Acoustic phenomenon. Acoustic waves are reflected by walls or other hard surfaces such as mountains and privacy fences. The reason of reflection may be explained as a discontinuity in the propagation medium. This can be heard when the reflection returns with sufficient magnitude and delay to be perceived distinctly. When sound or the echo itself is reflected multiple times from multiple surfaces, the echo is characterized as a reverberation. Reverberation. Reverberation in psychoacoustic and acoustic is a persistence of sound after the sound produced. A reverberation or reverb is created when a sound or a signal is reflected, causing numerous reflections to build up and then decay as the sound is absorbed by the surface of object in the space, which would include furniture, people, and air. This is most noticeable when the sound sources stops but the reflections continue. Their amplitude decreases until zero is reached. Reverberation is frequency dependent. The length of the decay or reverberation time receives special consideration in the architectural design of spaces which need to have specific reverberation times to achieve optimum performance of their intended activity. In comparison to a distinct echo, this is detectable at a minimum of 50 to 100 meters after the previous sound. Reverberation is the occurrence of reflections that arrive in sequence of less than approximately 50 meters. As time passes, the amplitude of the reflection gradually reduces to non-noticeable levels. Reverberation is not limited to indoor spaces as it exists in forests and other outdoor environments where reflections exist. Reverberation occurs naturally when a person sings, talks, or plays an instrument acoustically in a hall or performance space with sound reflective surfaces. The sound of reverberation is often electronically added to the vocals of singers and to the musical instruments. This is done in both live sound systems and sound recordings by using FX units. FX units are the specialized in the generation of the reverberation effect are commonly called reverbs. The human ear cannot distinguish echo from the original direct sound if the delay is less than 1 by 10th of a second. The velocity of sound in dry air is approximately 343 meter per second at a temperature of 25 degrees Celsius. Therefore, the reflecting object must be more than 17.2 meter from the sound source for echo to be perceived by a person located at the source. When a sound produces an echo in 2 seconds, the reflecting object is 343 meter away. In nature, canyons, walls or rocks, cliff facing water are the most common natural settings for hearing echoes. The strength of the echo frequency is measured in decibels, sound pressure level, relative to the directly transmitted wave. Echoes may be desirable or undesirable. Desirable in sonar, undesirable in telephone systems. Radar. Radar is an object detection system which uses electromagnetic waves, specifically radio waves, to determine the range, altitude, direction, or speed of both moving and fixed objects such as aircraft, ships, spacecraft, guided missiles, motor vehicles, weather formations, and terrain. The radar dish or antenna transmits pulses of radio waves or microwaves which bounce off any objects in their path. The objects return a tiny part of the wave's energy to a dish or antenna which is usually located at the same site as the transmitter. Application of sound waves in technology. Parking sensor. Parking sensor systems use ultrasonic proximity detectors embedded in the front and or rear bumpers to measure the distance to nearby objects at low level. The sensors measure the time taken for each sound pulse to be reflected back to the receiver. Depending on the speed of the vehicle and the distance to the obstacle, the system will warn the driver by visual and or audible means about the risk of collision. The feedback to the driver will generally indicate the direction and proximity of the obstacle. Warnings are deactivated when the vehicle exceeds a certain speed and can be switched off for situations such as stop and go traffic. Radiology. Radiology is medical specialty that employs the use of imaging to both diagnose and treat disease visualized within the human body. Radiologists utilize an array of imaging technologies such as X-ray radiography, ultrasound, computer tomography, that means CT scan, nuclear medicine, positron emission tomography (PET), and magnetic resonance imaging to diagnose or treat diseases. Interventional radiology is the performance of medical procedures with the guidance of imaging technologies. The acquisition of medical imaging is usually carried out by the radiographer or radiologic technologist.